Okay, so our goal here is going to be to write functions representing translations and reflections, write functions representing stretches and shrinks, and then also to write functions representing combinations of transformations. So all those things we've been talking about, we're going to combine and give a multiple items at one time. So here we go. So I would like you to write a function g whose graph, thank you, is going to represent the indicated transformation of our original function was 2x minus 5, and we want to translate that 4 units to the left. So take out a piece of paper for some notes. Jot down the function and what you're supposed to be doing, and then think about what you think that answer is going to be and write that down, because it doesn't help you to take notes if you only write down what you think the answer is. So we're transforming f of x equals 2x minus 5, and we want to translate it 4 units to the left. And then write down what you think that translation is going to look like. So what are we going to do? If we want to take 2x minus 5 and make it go 4 units to the left, we're going to add 4. Very good. So instead of 2x minus 5, it's now 2x minus 5 plus 4, because plus 4 is going to make it go 4 units to the left. And when we simplify that, what are we going to get? 2x minus 5 plus 4 is what's a negative 5 and a positive 4? Minus 1. Okay. Correct. Yep. Usually we would call it g of x, not f of x. The original function was f of x. We've modified it now. It's now a g of x.
Which she knew, so she doesn't know that you didn't learn this. So f of x, they're saying of f, and they want you to write a function g of x. So you're saying it started here, and now it's starting with f, so now it's different. Showing them it's a new replacement. All right, and you guys would know that too.
Okay. So tell me about this f of x. What parent would it normally have? What's the parent function for this? Absolute value. What did the absolute value look like? Is it a line, a parabola, or a U, or a V? A V, okay? It's already been translated a lot, right? We have 4 being taken times x. We're adding 3 within the x piece. This is our horizontal movement, our stretch already, and we're moving it 2 up to begin with. So it's already been modified from the original absolute value. But what we're asking you to do now is we want you to translate it 2 units down.
Anybody draw that today? Or like that is not draw for us, or tell us what the original one would look like? Did anybody do that? Or the guess? I could get marker board. You guys know what the 2 in front of the 4, or the 4 in front of the X is going to do? Yes, my dad. What these what's going to do? Make it wider. Okay. What is the 3 going to do? Like, move it where? Say it. The left 3.
Perfect.
Okay, so now that's good. It's wider. It's the left 3. What's the last 2 going to do to it? Yes, say it. 2. And what shape is it with the absolute value sign? A V. So that V is now wider to the left 3 and up 2 on the graph. You picture that? Want to draw it? And I know this is new. We didn't do absolute value a lot in Algebra 1 at all in Algebra 1. So we said left 3, up 2, here's our V. Now she's asking you to move it units down. Units down.
Very
That would be on
good.
the x-axis. What would the equation look like then? Do that equation. Oh, right. You don't even have to write it. You don't have to write 0 because it is 0. But what will we write to show that you get 0? Yeah, good.
Okay. So we took that function that they gave us. We took away 2 to make it go down 2. And now we simplified. And you guys took an extra step and did it all at one time. The absolute value of 4x plus 3 plus nothing. So we shifted it back to here for the vertex. Are we good with that?
Thumbs up, kind of clicking a little bit. Okay, good. Good, good, good. It isn't. We'll ask some questions to answer it. And answer it. You say it out loud.
Okay, next example. We have a function that's already been modified from our parent. And we want you to write the transformation if it's going to have a vertical stretch by a factor of 5. Absolutely. What's this equation going to look like with a vertical stretch of 5? Not quite. Is what makes it stretch vertically.
I asked you for movement. I asked you for shape.
Which one's going to stretch vertically?
Shape.
Yep. And what does that A have to be? It has to be, let me use your pencil. It's going to be f of x is 7 b1 a times the f of x. You take that A and put it out in front and multiply it to the value that gives you a vertical stretch. And it's going to be because stretching is going to be always A. Okay, so the other flip side. Okay. And That's the original one. We construct them initially. So this is the stretch vertically. That's where we're going to be multiplying it by the a on the outside. Okay. So this is the whole function. We're just going to put the 5 on. So it's going to be the whole function. So in front of the whole thing. Put parentheses, yep, absolutely. Awesome. This one's trickier. Okay, we said what do we think this one's going to be? Vertical stretch of 5. What do we think it's going to be? Five times x plus 2, right? Does that make sense? If we want to take it, something times it to make it stretch. We're going to put the a out in front. Now let's see what happens. I'm going to go to a little place that's called Desmos. This is a vertical stretch. We want it to go higher than it would have been. There's a website called desmos.com that can save us from having to buy a graphing calculator right now. We saw that the other day, remember? So let's put in y equals, and it was x plus 2 to begin with.
So use the y-intercept. Multiply 1 over 1. So subtract it, arrow to 1. Go up 2, put a dot, and go up 1 over 1, up 1 over 1.
What do you think? Did we stretch it vertically by a factor of 5?
I want you to notice that though it still crosses its street. Okay? It's not a parallel line. It goes up 5, which is what a couple people were drawing. And I love that you were drawing it, but you were drawing this same slope, but at 5. That would be the x plus 5.
That would be this h of x.
X plus 5.
You see that that's
different? Okay. So it's not at the end, because that's the y-intercept. That's changing the movement up and down. We change the shape of it, which is out front, in front of the x.
we're multiplying by it.
It's all kind of connected. It comes back. Here, get it.
Okay. Very good. Okay. So the next one then. Is that good? Yep, it is. It is awesome. Okay, so app on the phone. If you have an Android or a Google or an Android or an Apple device, you can download Desmos. And I have no problem. If that's a perfect academic use for your phones. Okay, updating Facebook, no. Using Desmos, yes. I will never yell at you if you're using Desmos to understand this, as long as it's not on a quiz or test when you're not supposed to use it. Yep. Okay, so absolute value of 2x plus 4 is our function now. And we want to shrink it horizontally by a factor of 1/2.
So shrink it into the a, the h, or the k. Shrink.
A. Give me an A.
Okay. Here's one started.
Mm-hmm. All right, what are your suggestions? What do you think it might be? Need more time to think? What do you think? Let's see. Anybody else have that? Good. Anybody have something different? Horizontal shrink. What else could it be? We know we have to have A, right? We tried it on the outside. Where else could we put it? On the inside. Let's see which one's right. It could be h of x equals 1/2 times 2 would be 1x plus 4. So we're thinking one or the other. We're not sure which, right? So let's put that in Desmos and find out. Okay. So we have 1/2 times the absolute value of 2x plus 4 is one of our possibilities, and 1/2, and just plain old absolute value of x plus 4. So my original was absolute value of 2x plus 4. Okay. We think it might be 1/2 times the absolute value of 2x plus 4. That gave me too many absolute values. And we're not sure. It could also be this plain old absolute value when we take 1/2 times 2 of x with our plus 4 at the end. Close this one off. Did it matter? They're the same, aren't they? Okay. So in that case, because nothing's being squared, nothing's being have any special powers or anything else going on with it, these two are one and the same. So which one is better from a simplified form perspective? Absolute value of x plus 4. Okay. All right. Now, did we do what we were asked to do? We were asked to give a function that is going to you've got to get these smartboards oriented. Horizontally shrink it. Is it horizontally shrunk from the original? Here was my original, right? Stretching would make it narrower. Shrinking it would make it wider. So we're good. Okay. Next one. Write a function g whose graph represents the indicated transformation of f. Now we've got our parent function, our good old valley, our v shape, our absolute value, and we're translating it 2 units to the right with a horizontal stretch by a factor of 2. So if we're going to move 2 units to the right, is that h or k or a? H. If we're stretching it, is that h or k or a? A. So we're going to mess with h and a. Those are the 2 guys we're modifying. Those are the 2 that we're using to modify it. What do you got? Does everybody agree? Does anybody have something different? That seem right? What else could it be? And that's what I'm trying to get to with them, is it might potentially be on the outside, right? Okay? That I believe this could be right. It makes sense, right? Everybody probably has this one. But let's see what would happen if we said, what if we put it on the outside? Because that's the distinction between the horizontal stretch and the vertical stretch. Absolute value, I don't think, is going to have an impact on it. It's the quadratic that it can have an impact on whether it's stretching it vertically or stretching it horizontally. Okay? A stretch horizontally means you're pushing it away from the y-axis. So if this was my original and I'm stretching it horizontally, it's now going to be something actually closer, because it's stretched horizontally. It's going to look like this. But that looks like a vertical stretch, right? Okay, and that there's a distinction between whether we put that at the A within the parentheses. If we had x minus 2 squared originally, if we say, what happens if we put the A on the outside versus what happens if we put the A just with the x? The A just with the x should impact the horizontal shift, where the A on the outside should impact the vertical shift. And I think it only happens with the limited functions that we have with the x squared, because absolute value is way too much like linear, and it's not going to have a big impact. A won't necessarily change. Okay? So let's look at it and see. We had absolute value of x and 2x minus the absolute value of 2x minus 2. think? Did we accomplish what we were trying to do? We were to shift it right to and make it a vertical stretch, right? Everybody okay? All right, one last one. Oh, I lied. It is assignment time. So your assignment is lesson 1.2. Someone look and see what page that starts on for me, the actual problems. Everybody find it? 16. On page 16, lesson 1.2, we're going to do number 1, and then numbers 2 through 34 even, and number 42. And if you get stuck tonight, I've recorded this as a video. You should have my audio, I'm hoping. So I will put it up on YouTube. It will be in the history.com Algebra 2 assignment for today. So history.com, choose Algebra 2. Today's assignment is listed, as soon as it loads, is listed here on the 25th in the calendar. And if you go to more details, it will tell you at the bottom where that YouTube video goes. Okay, I'll add that to it. So you can just click on the link and you can rewatch. There'll be a lot of pauses in there. You may have to fast forward through some of it because we stop and talk, or stop and wait, but that will be where it's at.